I'm Natasha and welcome back. So today we're going to continue our chapter 1, and that is sets. So in the previous video we discussed about overlapping set, and we did some practice questions on different subsets and disjoint sets. So in this video we're going to discuss about complement of a set. So our today's new topic is we're going to discuss all about complement of a set. So I've already written the heading, so what are we waiting for? So let's get started. Okay, so first we need to understand that what is complement of a set. I think you've heard about complementary, complementary angles, but yeah, this is like totally different. We don't have anything related to it. So complement of a set is just mainly trying to say that okay, so it is a set. It is a set whose elements does not belong to the given set, but it belongs to the universal set. So I can say the set of those elements which doesn't belong to a given set but belongs to the universal set are known as complement of set. So like the symbol that we can use for the complement of any set, like let's say we have set A, so the symbol of complement that we're going to use will be three symbols. Okay, you can use any one of them. Okay, so first one we're going to use is this one's the common, so it's like a comma, and or we can write only A, or we can write like this way. That's it. So I'll use this one, okay, because I think that that's going to be the simplest one, the simple one. So yeah, complement of set is the set of those elements which doesn't belong to the given set, but it belongs to the universal set. Okay, so let me write this statement, the definition which I've just said. So yeah, the set of those elements, which doesn't belong to, okay, so the set of those elements which doesn't belong to the given set, okay, I'll write it from here. So the given set, yeah, so the set of those elements which does not belong to the given set but belongs to the universal set, is known as the complement of a set. Okay, so I hope you all have understood about I think you've understood everything about the complement of a set. So we're gonna also take examples. So let's take example. Okay, so for example, let's take an easy example. So what should I take? Okay, so let's say we have set A, okay? And in set A we have let me say that, okay, so first, what if we had to find the complement of a set? Like we have to find the complement of set A. So first of all, we're going to see that, have a look at that, yeah, two things that are going to be permanent in the complement of set, finding the complement of a set is that first we'll have a universal set. The second, we have any type of set, like I can say set A we have for right now. Okay, so what I'm trying to say is that let's take an easy example so that we can understand about the complement of a set, and through the example, we'll be able to understand about the complement of a set. Okay, and yeah, there's one more thing that and yeah, it's like different from the difference of sets, and all these things I'll tell you. Okay, so let me write the example. Okay, so let's get started. Okay, so let me say set U is equal to the elements. Okay, I'll just write it again. Okay. Just wait a second. Yeah. Okay. It's like a little bit wet. Whatever. Okay, we have set U is equal to the elements 2, 4, 8, and let's say 10 and 12. And set A is equal to the elements, what I'll say is that, let's say 4, 6, and 8. And I'll add one more element in the, in the universal set that is going to be 6. Okay? Yeah, so let me just rub it. Okay. Just want to show you something, so... Okay, so it's a little bit wet, so I'll just try to write it. Okay, let's wait for it. Okay, so which doesn't belong to just doesn't belong to a given set, but belongs to the universal set. So it's like important that we're gonna have a universal set, and we're having another set which is like set A. So we have to find. So let's say then find the complement of set A. Find the complement of set A. Okay, yeah, so let me write it. Okay, set U is equal to the elements 2, 4, 6, 8, 10, and 12. Okay, yeah, so then we have to find the complement of set A. Got it? So let's solve it. Okay, so set U is equal to the elements 2, 4, 6, 8, 10, 12. So what is it saying? The set of those elements which does not belong to a given set but belongs to the universal set. So we'll have to just see, we're just gonna see, have a look at this set, universal set, and we're gonna find that which elements are not the part of set A, but they're the elements of set, universal set U. So we'll just have a look. So in set A we have 4, 6, 8 as the elements, and in set U we have also 4, 6, 8. But we're gonna have a look at those elements which are in the elements of set A. Like I can say that set, element 2, 10, and 12. They're like the elements of set U, but they're not the elements of set A. So what I'm going to say is that the complement of set A. So the complement of set A. So what is it going to be? So it's going to be 2, 10, 12. Okay, so the complement of set A is equal to the elements 2, 10, and 12. That's it. Okay, and you know what? I'll just rub this one. So, just to make a little bit more space. Okay. Oh, it's by mistake, so never mind. Yeah. So we're gonna have a look at it, just later. So yeah. So this is how we can find the complement of set A. So of any set we want to, but yeah, one thing is common in all the sets, that we're gonna have a universal set in it, and you know what, we're gonna have a look at some properties of the complement of set. Okay, so now some properties of complement of set. Okay, so first one property that we're gonna have is Yeah, what I was trying to say is that symbol. The symbol that we're going to use can be in 3, and like the common, like the usually we use this symbol, okay? But we have some other symbols like symbol of complement of any set. Okay, first one we have is like this way. Second one we have is like only the A, and the third one we have is like this way and then capital A. Okay, and yeah, the set of those elements which does not belong to a given set. Yeah, here A will come. So the set of those elements which does not belong to a given set but belongs to the universal set is known as the complement of this set. Okay, yeah. So let's move on. So now we're going to do some properties. So first property that we'll have is going to be like maybe it can be common for you. And so let's have a look at the first property. Okay, so the first property we have is, wait a second, let me just check the camera, is it like on focus or not? Okay, yeah. Okay, so it's clearly on focus, so let's just continue. Okay, so the first property that we're going to talk about is going to be the complement. The complements law, okay? Complement law. Complement laws, okay? Yeah, so the first one, there are parts a little bit. So first one is A. Union A is equal to U. So union of set A with itself is equal to U. But that's like kind of more it's kind of different from the topic that we're discussing. So it isn't like related to complement of set. So we're going to talk about, we're going to also have a look at the, the properties which are going to be there. Well, all the properties are all going to be related to complements of set. Okay, so the first one is that what I'm trying to say is that, we're going to talk about the complement. So A union A is not going to be but I'm talking about, but one of them is the complement. So let's say this one is the complement. So set A union complement of set A is equal to, set U, which means the universal set. And the second one that we're going to have is like if the union, like if the intersection of complement of set A with the set A is going to be is equal to phi. Okay, like you've already heard about phi. So if we're going to do the intersection of set A with its complement that we're going to get phi. And if we're going to do the union of the set with its complement, it's going to be union set. Sorry, not the union set, I'm talking about the universal set. Okay, so these were some complement laws that we're going to use. Like it can be any set. I can say set B and the complement of set B, and set C, complement of set C, like anything, okay? Yeah, so let's move on to our second law that I'm going to write here, okay? De Morgan's law. I think you've heard about it. De Morgan's law. Okay, so the first law that we're gonna, we're just gonna look is going to be, these are the De Morgan's law. So let's have a look at them. So if we're going to do the union of a set with another complement of set. So what I'm trying to say is that let's say, okay, A union B complement. Okay, so A union B complement. So like their whole complement is equal to A complement. So complement of set A intersection complement of set B. Okay, so if we're gonna do a union of two different sets, like if we're gonna do the union of two different sets and they're actually the components, then they're gonna be equal to the intersection of both the complement of those sets. Like we have set A, then A complement intersection B complement. Okay, if we have union, well, we're gonna have in the result, we're gonna have a look at the intersection. And if the second, right, it's opposite. So what I'm going to say is that A intersection B complement. So is equal to A complement union B complement. Okay. So now in this one we have, right, it's opposite. So in this one we have, we have some union. And in this one we have intersection. So it's going to be right, it's opposite. So A union B, the complement of A union B is equal to A complement union B complement. Okay, A intersection B, A intersection B. The complement of A intersection B is equal to the complement of set A union complement of set B. And the first one we have is the complement of set A union B is equal to the complement of set A intersection B. Okay. Yeah, so always remember, so these are the De Morgan's law, and the first one property, that was complement clause, and now we're going to discuss about the third property. Okay, so what is going to be our third property? Okay, so third property is also the same, that like it's not that what I'll say is that it's not that different too much. So it is actually the law of double complementation. The law of double complementation. Have you heard about it? The law of double complementation. Law of double complementation is equal to what? So what I'm trying to say is that double, like we're going to do the law of double complementation. So the complementation double. So double complementation. So let's have a look, like set A. We have set A. So this is going to be the double complementation of same set. Same set. Have a look. What I'm trying to say is that it is actually the double complementation, like we have set A. So double complementation of set A is going to be like this way. The first one in complement when we're going to write is going to be A complement, then bracket after that complement. So it's like the double complementation we have. Okay, let me write this. So what is it going to be? What it will be equal to. Okay, so let me tell you that it is going to be equal to set A. It is going to be equal to set A. So the double complementation of set A is actually going to be, set A. That makes sense, okay? So because, it's like the double we have, and we're gonna what if we have the set B? So the double complementation of set B is going to be equal to set B. That's it, and nothing else. So this was the third property of complement of set, and now we're gonna move on to our fourth property. That is gonna be that's probably going to be the last property of complement sets, or complement of sets, whatever you want to say. Okay, so it is the law of empty set. Law of empty set and universal set. Okay, so we're going to have a look at the law of empty set and then the law of universal set in complement sets. Okay, yeah, so let's have a look at it. So first we're going to talk about the empty set. The empty set we're going to have is going to be phi. So we're going to talk about their laws. So first of all, we're going to have a look at phi. So phi is actually, what if we have to do like the complement of phi? The complement of phi is equal to what? What it can be equal to, like, if I'm going to say like that makes no sense. Like, we're not going to talk about it too much. So, like, let's understand it in an easiest way. Okay, so the law of empty set and universal set. So first we're going to have a look at the empty set. Empty set we have is phi. Okay, So like, what if we have to do the complement of phi, the complement of empty set? So what is it going to be? So actually the complement of phi is equal to universal set. Of course it is. And what if we have to now the universal set? And what if we have to do the complement of set U, the complement of universal set? Then it is going to be is equal to phi. So they are related to each other. So if I'm going to do the complement of phi, of empty set is equal to universal set. And the complement of set U, which is universal set, is equal to phi, the empty set. So they're exactly opposite to each other. So that's what, those were some properties, those were the 4 properties that we discussed. And, so that's all for today. And in the next video, we're going to continue after this topic. Yeah, we're going to discuss about, we're going to discuss about some the practical problems on, intersection and union of sets. So that topic is going to be really interesting, the other video. So you know what, see you in the next video, and thanks for watching and have a great day.